Once again, welcome to this the next class on the Linux programming and scripting. Today we will be continuing the Perl programming language. So before I go into today's topics, let me just recap a little bit as to what we have done so far. In the first lecture of Perl, we started by actually looking into some basic language constructs. We wrote programs to write like hello world. We also kind of understood how Perl reads the files, or Perl reads input from the terminal and then outputs into the terminal. We also understood a little bit about the basic data types, that is a scalar data type and then an array data type. Array also we introduced something called associative array. And essentially at that time we said that basically okay, string is another type of an array, and then basically string is again an array of characters, and that's why it's like another array. And then in the last lecture we learned a little bit more about strings as a data type. Basically we learned that we can have strings of any length. The entire book can be considered as one variable, a string variable. And then we also did some string matching. I hope you remember the S slash, and then basically the first matching that we learned was equal to followed by the tilde, or the wiggly character that's on one of the keys in the shift keys in the keyboard. Then that wiggly character, along with that we said basically if you add an S, then we can do a substitute. Essentially we can not only match but also we can substitute a character for another character. Then we also did basically some other types of matching. One is the transliteration that we talked about, which is represented as TR, and then here essentially we can change the characters from one case to another case, or substitute for some characters with some other characters, things like that, where a lot of other types of adjustments that can be done. Then we also talked about how to open a file and then read a file and then how to close a file. We also talked about how to write into a file, which is using that ampersand, and then we introduced basic concept of what is the file handle, essentially, which is essentially the pointer to the file using which Perl actually writes or understands the concept of a file. So we also know that there are specific files that are already built in functions, which are the less than stdin greater than, or less than std out greater than, and then we also saw the less than standard error std err and greater than. Those are all for the predefined file handles, which are essentially used to read from and write into the terminal, or essentially for the program itself. Other than that, if you are defining a particular file handle, we need to first open that file and assign a name for the file handle, and then once we assign the name, then we can use that name from that. So that's the thing that we learned about that, and then we also actually saw some control structure. So that the control structure that we learned was basically like the if then else if else if else, basically that is the if then else construct, and we learned a little bit about how to write those things. And then we also started talking about the function calls essentially. So the function calls essentially like so this is something that basically we know that a function call can be specified basically like as a sub and then the function name, and then we can also specify some argument, and then once we write the function and then we can call that function into the in program by using the ampersand function. Then we learned about some escape characters. These are mainly for escaping special functions, and here actually like we kind of distinguish between the string with like just the quote as well as the double quotes. So the key difference is that inside this one anything that you write is just literally like translated or literally kept, whereas here you can have additional variables and then the variables will be replaced at the runtime by the program. And then we also talked about a small quiz, which is what I wanted to talk about in the as the first thing. I actually asked you what is the meaning of this the backslash n. As you know, like the backslashes are the is basically the escape characters essentially. So within the code, if you specify backslash n, what happens? I also asked you to actually try to run this program. Basically, the $A equal to single quote backslash n. Then $B is equal to the double quotes $A and backslash n, and then now you print $B. What happens? So I hope you tried this out. If you haven't, you can still try it out. But I'm going to give you the answer essentially today. So the answer is actually for printing the $B, it's the backslash n. Basically, this is also equal to backslash n. So as you know, like the backslash n we studied in the escape side, basically like just specifying backslash n means that it's a new line character. But in this case, since we are escaping the backslash, it's basically this is treated as a literal, and then since this is treated as a literal, even the n is also treated as a literal. As you know, like within the single quote, only the backslash and the tick or the apostrophe are the only two characters that can be escaped, and it happens to be one of them. So this is just a literal backslash n. So even if you just print this out, it will be backslash n. Even if you are using it within this variable and then you're printing it out, it's only backslash n. The second backslash n is essentially treated as the new line, so the program goes to the or the cursor goes to the next line. I hope this is clear. If you have any other doubts, please feel free to email me or your TA, who should be able to answer these kind of questions. So with that, we will start talking about today's topic essentially. Today we will be continuing our discussion on the various we're continuing from the escape characters. We will go into more operators today, and then we will also look at some of the scalar variables. We'll start talking about the scalar variables. We introduced the scalar variables in the couple of lectures ago, and today we will go more deeper into that scalar variable. As I mentioned, one of the goals for this course is we will start slowly building things so that by I mean, we are not going to be like, I mean, we will cover some of the basic information and things like that, but we will start building this programming knowledge right from the get go. I don't want you to study all the basic stuff and basically like every topic one by one, and then at the end you can put together and write a program. That's not the intent of this course. As you go through the course, you will be able to program smaller bits and pieces of Perl, which is essentially even the goal for Perl. I mean, somebody who takes Perl is intuitive, so that you can start coding even the very first day. You don't have to go through a course of many days before you start coding. Basically, as you learn, we build small scripts, and then we will build it up, and then finally, like by end of the course, you'll be able to do whatever programs that you want very easily with Perl. So let's look at some of the operators. So the operators in Perl is a superset of the other languages that are there, the C, Algol, and Pascal. Basically, it also provides automatic conversion between the strings and numbers. There are arithmetic operators, so operators are not limited to just this arithmetic operators, but the arithmetic operators are essentially addition, subtraction, multiplication, division, modulus, and exponentiation. So we will study these operations and how to use these operators in this section. There are also like relational operators for numbers and strings. They are both are separate. If you have a number data, then you use one type of relational operator, and for strings you use a different type of relational operators. There is also a concept of this concatenation operator. Concatenation means joining strings. So if you have like many strings that you want to put together, there is a dog in my house, and each one is a separate string. You can put together using the dot operator. And then for strings, we also have a repetition operator, just the X, which is very similar to the multiplication operator here. The repetition operator essentially like works on the strings, and basically it produces multiple copies of the string. We will see like, I mean, how this, and you know, the regular multiplication operator is this asterisk, so the star symbol, which is shift 8 in your keyboard. So we'll see like some of the examples as to how to use them. And before that, let me talk about the relational operators. This is the table that we saw previously in, I think, like a couple of classes ago. I want to reiterate once again. So in the relational operations, basically, like, I mean, we have a set of one for numbers and one for strings. So this is the number one, number relational. And then this is for the string relational. So equal to is straightforward. This is to compare. For EQ, it's basically like two strings whether they are equal. This one is like if two numbers that are equal. So this can be, when I say number, basically it can be like variable. So you can say like $x equal to 1. This compares whether if x has a value of 1. And here, like, you can also say like $y EQ my name, something like this. So that this compares whether the $EQ is my name, and then it does something. So this is the EQ operator. The less than symbol is for the less than, greater than is for the greater than, and less than or equal to. These are like some of the things that are provided. You may wonder, like, I mean, how do you use like less than, greater than, LE, G, and all for the string operations? Again, the equivalent numerical value is used. Like, so for example, like you can actually have a string which is like 12. So if it is a string operator, then you will say like, I mean, if my dollar number is less than literal 12. So here essentially, like, I mean, you can again compare a number against the literal string as well. So same thing, like, I mean, the greater than or equal to, and then finally like not equal to. We will use some of these things in various programs in the coming lectures. You also have some assignments which will be using these concepts. So here are some examples. So 1 plus 2, straightforward, it's 3. This one 9.8 minus 7.6 is 2.2. Again, you see that basically you don't have to explicitly specify any floating point, as you know in Perl everything is this floating point. 3 times 21, 63. Again easily understood. 14 divided by 2, 7. 10 divided by 3 is a floating point number, 3.33333. Again, Perl has basically the precision is limited by what your computer allows. And then the 10.2 divided by 0.3, 34. These are pretty straightforward operators, essentially, like, I mean, so this is the addition operation, subtraction, multiplication, and division. So these are the basic operators. Now let's look at some other operators as well. So this one is the modulo operator. So 10 modulo 3 is 1, which is the remainder essentially. So and then 10.8 modulo 3.2 is 10 modulo 3, same thing basically. And this is the exponentiation. So 2 power 3 is actually 8. So here, if you try to do this 17 less than 7, the answer is false. Whereas 17 less than 7 in the string operation, the answer is true. So some of these things basically based on what the operator you use is different. So if you are a numerical one, then you need to use this, whereas this one is used for string operation. This is mainly because when you compare the first one, and then it produces this answer. And this is the concatenation operator, the dot. So it produces just a single one, no space here. So everything is joined together. And here, essentially, like you can look at this one as you shouldn't have this W. Actually, that's a typo. But you can see that actually it concatenates a literal string with the new line, and basically it combines it into one. So now we look at some additional things. Basically, like one thing that we talked about was this repetition operator, which is the X operator. So the X operator essentially multiplies that hello by 3, so you get this as the output. Then the word x 2 plus 1, and 2 plus 1 is in parenthesis, that prints out world world world. So the parenthesis is actually operated first, so 2 plus 1 becomes 3, and then 3 times world is essentially like the same. Here again, when we use the x operator, the 3 plus 2 is evaluated, and then that is essentially 5, and then 5 times 3, so it is 555, and 5 is treated here as a string or a literal. but at the same time 3x 3 plus 2 is actually 33333, which is basically this 3 plus 2 is evaluated first, which is 5, so it just repeats 3 5 times. And hello times 2.5 is basically like only like 2 times it's printed out. So the last one is just omitted, and if you do it anything less than 1, basically it's nothing is printed out. So I think this is clear. You can actually play with these operators to see, like, I mean, what various outputs are. I'll also give some exercises later on to work on these operators to see how you can make use of it. So now let's go into precedence. One thing that I talked about here was this parenthesis, basically like how parenthesis changes the precedence. Basically, instead of world times 2 and then plus 1, it's actually like the 2 plus 1 is evaluated first and then world. Same thing like here we see like some precedence operators in play. So how does Perl understand this precedence? Are there any rules behind this? How to evaluate the operations? So that's what we learn in the next section. Basically, the rules are fairly simple. Essentially, for all the operators found in C, the operators have the same precedence as in C. So this includes like the plus, minus, the multiplication, division, etc. And then you can check a table for the lower to higher precedence. I'll talk about that table in the next slide. And then for the operators at the same level, it's resolved by associativity. Okay, so there are two ways basically. One is there's a table which goes from top to bottom, and then we also have some rules regarding the associativity, which is used to resolve for the operators at the same level. So what do I mean by this? We will talk about this, and if this is not clear, like, I mean, actually there will be more chances that we will be covering this. So here I talk about the associativity and then the operators. So the precedence goes from top to bottom. That is number 1. Okay. So if you see like one of them here, not, and then one of them here, say multiply. So this takes the first precedence and then before this. So basically, like, you have to evaluate the multiplication before you can use the not. But what if there are couple of knots in the same line? So we go back here and then we say that basically the precedence is from right to left. So you first evaluate the rightmost one. So for this one it goes this way, whereas for AND it's actually going this way. And then OR and XOR again goes left to right. And then so we can look at various things. One is so there are various operators here. Some of these things we haven't actually like learned. This one we have learned, which is the exponentiation, which is again going from right to left. So this way. And then this unary operators are all like same thing basically, whereas some of the comparison operators goes from left to right. Here it's again like left to right. All these things, like there's a comma operator, plus, minus, they're all going like this, and then you can see that actually this plus and minus have a lower precedence than this multiply and divide. So if you have the plus minus, then essentially that will happen later than the multiplication and the division, which is the normal rule anyway. One other thing to note is basically the parentheses will change this precedence order. So if you put anything inside parentheses, those are evaluated first and then before assigning this precedence table. So there are all the operators that are mentioned here have this precedence. So I want you to go through this. I have some examples in the next slide, which we will go into now. So here are some examples. So the change dir is a function call chdir, and then basically the $foo is some variable, and then we specify, like, I mean, okay, if this condition is not true, then die. That's the meaning of this particular statement. We will talk about these kind of statements in the next section or in the coming section, but I want you to pay attention to this one. So here we specify this without any precedence, basically, like this, right? That's the same as writing first the chdir foo and then the or die. So this and this are exactly the same. If you put a parenthesis inside the foo and then doing the same thing, basically that's again the same. This is also exactly the same, where we basically like changed the with no space, and basically we just straight away declare the $foo as its argument, and it's the same thing here. And then finally, like even if you say like change the plus the $foo, which is an addition operator, and then say like die, and then again that's exactly the same. That's because the addition takes precedence over this relational operation. So this relational operation, I should say once again, is on. So just in case. So now when we use a multiplication operation instead of an OR, for example here, then this is same as the change there with $foo times 20, because now this one has higher precedence than this relational operator. So we go back to the thing. The relational operator here, that's of a lower one than this the asterisk. So again you see that basically how the precedence work. So again, when you do the chdir $foo, that's the same as before basically. So here you can see that the first statement and the second statement are the same, whereas here first statement and second statement are different. But the second and the third are the same, because now the parenthesis takes precedence over the star, and then essentially, like, I mean, it basically so that $foo is associated with change there instead of 20, whereas in the first statement, without any parenthesis to modify the precedence, basically the foo is assigned with 20. Another interesting one is this one. Here we put the parenthesis around foo, but we add an additional operator. So you can see that actually, like, again, this has a higher precedence than the addition. So it's again it's foo times 20, and that's time in the change term. Then we are actually generating some random numbers essentially. So this is random 10 times 20, which is essentially like random 10 times 200. I mean 10 times 20, which is 200. So it generates a random number between 0 and 200 here, and essentially you can see that actually that's how this is taken. Whereas if you say like rand 10 in parenthesis times 20, then it generates a random number between 0 and 10, and then that it multiplies by 20. So you can look at this one basically, like here there are maybe like 200 combinations, and out of that one is chosen. Here you have only 10 combinations, and out of that one is chosen. So the answer may be like still, like, I mean, the range is same. Basically this has 0 to 200. This also has 0 to 200, but you have only like 10 different values, whereas here you have 200 different values, and it is choosing from one of them. So these kind of precedence metrics and this whole this discussion will help you to write programs which you want to do it properly. Because in this section, basically, let's say like you want to generate a random number or some task which you think that basically which is a combination of two different types basically, and then you choose to represent this way, which is the correct way. But if you are doing this way, then you are actually like, I mean, you are not actually getting the full range to generate the random numbers, because here the random numbers generated are like 20, 40, 60, 80 or multiples of 20, whereas here it's multiple of 1, so it's 1, 2, 3, 4, all the way to 200. So that is one way of looking at it. So depending on the applications, you can really generate, and sometimes, like, I mean, if you do this, then the reduced set, even though the range is same, you're actually biasing it with only like 20 different values. So here is one quick question, again regarding the same precedence that we talked about. Here essentially, like, I mean, I'm declaring an array, and the array contains values 1, 3. Then I introduce a function called sort. Sort is, you can think of the sort as sorting multiple values, and then I give like 4 and 2, and then I say print $array. So what do you think will be the output of this program? So I'm going to give you the answer, of course, for this one, because it may be good to actually practice these kind of problems, because again, this is the kind of things that you can do, because Perl is a very flexible language. So there aren't like hard and fast rules on things. Basically, you need to understand how the precedence work so that you can write the appropriate program. This also actually adds additional complexity to the language, and which makes debugging pretty hard, because a person may have written one way his or her algorithm, and then if somebody else wants to debug it, now they need to understand what was the thinking behind writing the program before they can modify it. So again, it becomes very hard, because all these complex syntax, how do you actually sort through those syntax? Again, I want to advocate for a program that is very clear and concise, but at the same time, you know, when you go and appear in interviews, they will ask you to understand the intricacies of Perl. So I think you have to know this, but in practice, make sure that you don't really complicate the programs, and keep it simple. So let's see what the output is. So the answer is 1, 3, 2, 4. So here there are a couple of things that I want to note down here. Number one, implicitly the sort is actually applied here, but within that, basically, like, I mean, the comma operator gets the precedence. So first the comma is operated, which is like, now you get only 4 and 2, and then on which the sort is operated, so you get the result as 2, 4. Then once that is performed, then you have the other two comma operators. So the comma operators are just basically more like concatenating those things. So the array is actually comprised of just 1, 3, 2, and 4. So the answer is this. I think you can actually run this program and check it out whether you get the same answer or not. Okay, so let's move on. So as I mentioned, basically the operators can be operated on both strings and also the numbers. So if a string is used in a numerical computation, it's automatically converted into its equivalent numerical value, which is a decimal and a floating point value, decimal floating point value. So couple of things to note. One is the leading white space characters are ignored. So if you start with blank number and the blank is ignored, only the number is taken, and then the trailing non-number characters are ignored. So if it is um, NUMBER space NUMBER, that's basically it's converted as just 0. So that is a non-number string is converted to a 0. So the numerical value is used in the string operation. It's expanded into whatever it would be printed. Okay, um, so let's look at some examples. So here in quotation it's 1 2 3 Fred times 2. What will be the output for this? So this is the same as just saying 1 2 3 times 2, because the leading this blank, this is ignored, and then the trailing, all these non-number characters are considered, they are taken to, they are just changed basically, they are ignored also. So the result is just 123 times 2, and the reason why this is the true is because of this. If you say like 1 2 3 Fred x2, then the answer will be like 1 2 3 Fred, will be a space, and then space, and then again space 1 2 3 Fred. Okay, let's look at one more example. So what will be the answer for this one? So as you know, like the parenthesis operation is the first, and so parenthesis performed that has the highest precedence. Along with it there is a star, so this has the next precedence. So 3 times 14, 3 times 4 is executed first, and then the answer is 12, and then that is concatenated as a string to x, so you get x12, and this is the concatenation operation. So the bottom line is like most of the time we don't have to worry whether we have a number or a string, because we just perform those operations and basically like we'll just see what is the outcome. The only issue here will be when we use like relational operations that we saw earlier. 17 is compared with 7. Actually the 17 is greater than 7, so that if you are saying like 17 less than 7, that will be false. But in the string terms, it's actually like 1 is compared against. So in 17, if you say LT7, now 1 is compared against 7 first, and then 7 is compared against whatever is next here. But here there is nothing here, so 7 comparison is not there. Only the 1 is compared against 7, and 1 is really less than 7. So this becomes true. So when you are writing scripts, you got to watch out for what exactly you want the results to be, because if you do something like this and use the wrong relational operation, then you will get a result but which you wouldn't expect, and then as a result that will cause issues and it's harder to debug. Okay, so let's also introduce the scalar variables. We actually went through this a little bit in the first lecture. The scalar variable holds a single value. It's either a number or a string. The general syntax is essentially it's a letter or a digit, essentially with a prefix of dollar, and then you can actually have an underscore also. So other characters are not allowed in the variable, and essentially like I mean so they are not, it basically rejects the additional variable additional characters, and it is case sensitive. So you can say like I mean same thing like I mean dollar name is not equal to dollar name. Okay, this is yeah, true in both this as well as this. You can have different values for these things, and then for the name itself there is no length limit, so you can have however you want. So let's look at how we can use them basically. One way to use the scalars is through an assignment. So you can assign values to the scalar variables, and which you in turn you will be using it for various things essentially. So for example here a typical assignment will be $A equal to 7. And then we will say like okay $B is equal to $A plus 7. So here you notice actually like there is this is the equality operator. So here we just assign a value or assignment operator where we actually assign a value to this particular variable. This is also sometimes we can call it as initialization, where we first assign a value and then we can do some operations on it. Here we assign $A plus 7 to this one. So if the $A changes say to 9 at some point, then that will be reflected here. So currently this is equal to just 14, but it can change based on the value of A. And then here you can see basically that $C is weak concatenated with $B. So can somebody say what will be the answer for this one? It's that is weak 14. So that's the way that we can write it. And then here we say like D equal to in parenthesis A equal to 3 plus 4. So now what will be the value for the D? So here essentially like I mean you can think of the parenthesis actually change the precedence, so you need to evaluate this first and then do this. So when we evaluate this is an assignment operator when 3 is assigned to A, and then that plus 4 basically becomes $D is equal to 7. Here it's basically like a continuous assignment essentially when we are just assigning to $F which is equal to 7, so both of them will become 7. So I think this is the way that we can change the precedence essentially, and also we can move some operations basically on the various variables. The scalar variable is one of the most widely used variable in Perl. Pretty much most of the operations that we do is using scalars. So the scalar variable we will learn a lot of things about the scalar variables in the coming lectures. So let me also go into the binary operators essentially or binary assignment. So essentially this is very similar to C. If you know C, then this will be fairly easy. The order of evaluation is unspecified. So if we go back to our the metrics that we talked about here, so the some of the pluses are there basically, very similar to this one, but they don't have any kind of associativity. So now let's see like I mean what that means. So here a equal to 5 and b equal to 5. So it's a standard that's given. So now we are assigning a plus equal to 7. First of all, what does it mean? This means actually that it's a $a equal to $a plus 7. The reason why this order is evaluation is unspecified is because it doesn't matter how this thing is evaluated. Okay, so in this case the $a will have a value of 12 because it's basically that's the value that it settles at. Okay, so whether this is evaluated first, this is evaluated first, it doesn't matter. This is so this introduces some kind of ambiguity later on. We will talk about that actually. So and then now we come to this basically. So here again same thing. So this is like $b is equal to $b times 7. So that's why we get 35. And then there's also like this concatenation operation which can always be a binary assignment, which is a lot of people use this shortcut for binary assignment where they say basically say $string equal to days and then say $string dot equal to of life. So then now the $string will be equal to days of life, something like that. So it's basically like I mean we can actually create new strings very easily by using this binary assignment. So now we come to this last example. $b is equal to $a plus equal to 2 and then star $a minus equal to 2. So what will be the answer here basically? First of all, this assignment is the worst assignment. So never do this. It's bad. Why is it bad? The reason why it is bad is because inside this whole thing this order of evaluation is unspecified. So we don't know like I mean whether this is evaluated first or this is evaluated first. So now how will you resolve this and what will be the answer? I want you to actually test this out before I give you the answer. Because again like I mean this is one of the key points of understanding that we should be able to understand how this is done. So I'm going to actually stop at this point. I'll go and do a recap of what we learned today, and then we will pick it up from this. Meanwhile, I want you to experiment with this particular assignment, see what happens, and explain why you are getting that answer. So first of all, find out what your answer will be when you do this. So follow this one basically. $a is 5, $b is 5, or actually like just make it $a as 5 and then just do this operation. See what you get. Because again this order of evaluation is unspecified. What does that mean? Find out and explain to me in the next class what happened, and in fact I will also explain to you as to what you should have seen and why you should have seen that. Okay, so let's just recap what we learned today. So we started with some operations basically. So we went through like the various operators. Essentially in Perl we have a number of operators. Basically it's a superset of C, Algol and Pascal. And there is automatic conversion between strings and numbers. This we saw basically how we can do this. And in Perl actually there are arithmetic operators addition, subtraction, multiplication, division, modulus, we saw that is the percentage, and then exponentiation, which is the double asterisk. And then we have relational operations, and one set for numbers and one set for strings. Actually, we don't have a data type where we can operate these things on. We can easily operate the string relational operator on the numbers and then the number operator on the strings. Even though, like, I mean, when we operate the numerical relation operators on strings, it can complain saying that, hey, you are using a wrong syntax here. But if you use the string comparison for the numerical side, it won't generate any issues. Then we also looked at the concatenation operator for strings. Then we also studied about the string repetition operator, which is the X, basically for multiplying numbers. Then we went through all these various operators. We also studied some of the precedence order. So this is one of the key things that we will again revisit in the next lectures. In precedence, essentially, like when we said that basically in Perl the order of precedence is, first of all, it goes from top to bottom, and then it also follows whatever the associativity rules that are specified in for the same operators. You use just this one row essentially. So and then that also varies essentially. For some operators it's right to left, and for some operators it's left to right. For example, the not functionality is actually from right to left, whereas an and, an or, and XOR are all from right to left. I mean left to right. So this we learned, and then we learned also, like, how to answer some complex questions. Then we studied about the conversions essentially, which is how can we use string in the numerical computation, and then how can we use numbers for comparing in a string way essentially. One of the conversion thing, the rules are essentially very clear. One is when you are converting from a string to a number, the leading white space is ignored, and then the trailing non-number characters are ignored, and then whatever is remaining, that's your number essentially. And then the numerical value used in a string operation basically is expanded into whatever it would be for when it will be it will be printed. So this is something that we also saw. And then we went into the scalar variables. Essentially, like, these are scalar variables, are variables that hold a single value. It's usually represented as dollar followed by number of letters or digits essentially. So you can have like $123 as a scalar variable that can hold some value, even though we don't want to. We always typically have a letter essentially as a starting point. Actually, here also, like in syntax, we start with a letter, then we can have any digits or letters, or even an underscore. So we will. So the $123 is not allowed as a variable, whereas $A123 is okay as a variable. So again, the scalar variables, the variable names themselves are case sensitive, and there is no length limit for the variable names. So I want you to keep in mind about these rules and this syntax basically when you are writing the thing. And I will ask you to follow like one type of syntax. You can, so Perl allows this underscore, and people typically write like name or me underscore 123 as one of the variables. Or you can specify like mine my Perl as another variable. So they use underscore to link various words to form a variable. You can also use camel case because it's case sensitive, and basically you can say like my as one word, or me 1, 2, 3. So you can choose one style or the other, and usually like people choose a style and it sticks to them for life, so to speak. And people who are well versed with Perl, they typically choose this with underscore. So I would like you to choose whichever one that you are most comfortable with in representing various variables. Then we also learnt about assignments, the two types of assignments. One is a regular assignment, which is basically assigning values to a scalar variable. We use like various operators to achieve that assignment. So assignment, you can think of that as an operator which is represented by equal to, and then we use various types of assignments to feed into that particular variable on the left hand side. So we also learned about this binary assignment operator, which is these kind of operations essentially, which is two operators linked together in here also. So basically one thing is the order of evaluation on the operands is unspecified, so which one is evaluated first is not known, even though like I mean most of these kind of cases we evaluate basically it's same as saying a equals a plus 7. So the plus is evaluated first before the assignment. So a will get the value as 12 or b will get the value as 35. But when you use it with these kind of complicated way, where this you're using one type here and another type with the same um, variable, the value sometimes is not what we expect. So I also gave you this example, and basically this will be a quick quiz for next time to see whether you understood this. Basically run this command and see whether what the result you get, and then you can share it with me. I will also share my result with you next time, and give you an explanation as to why I see that value. So hopefully I think this is now where we are getting like more and more deeper into Perl. So thank you again for listening. Thanks a lot. See you next time. Thank you.